Hello everyone, I'm Mason from Richtek Central Marketing Division. Welcome to the webinar hosted by Richtek. Today's topic is high accuracy, low IQ battery power management solutions for wireless portable applications. Before getting started, let me briefly introduce our company. Richtek Technology was established in 1998. Currently, we have more than 1,200 employees worldwide. Richtek has been listed in the ranking of the top 5 global power management IC suppliers. Last year's annual revenue reached $1.2 billion US. This picture shows our offices around the world. Our headquarters is located in Hsinchu, Taiwan, and we have other offices in Asia as well: Taipei, Taiwan; Tokyo, Japan; Pyongyang, South Korea; Beijing, Shanghai; Suzhou, Shenzhen, China; Silicon Valley, North America; and Netherlands, Europe. We also have R&D centers in several locations worldwide. Our headquarters Hsinchu, Taiwan; South Korea; Japan; and North America. We have been continuously enhanced our R&D capabilities to stay in a leading position. After briefly introducing our company, let's get down to business. First of all, let's talk about the importance of quiescent current and why quiescent current becomes a key feature in wireless devices. It is because IQ plays an important role on power saving, whether a product has less power consumption or not. In this slide, let's take a 200 milliamp hour battery for example. The system takes 130 milliamp hour of power, and the IC in standby mode takes about 90 milliamp hour. But if we use the IC which has only 360 nanoamp IQ reduced from 1 microamp, the overall reduction is about 36%. As a result, the standby power consumption is down to 30 milliamp, which reduces 1/3 of the original power consumption. It can be seen that the life cycle of a battery in the system will increase by 63%, and it can also support smaller batteries. In addition to save power and extend battery life, the device can also be designed smaller and more refined. By far, I believe you can understand that why quiescent current becomes more and more important. Therefore, Richtek has been continuously improving in this feature and has successively launched a series of low power consumption power management ICs. We also provide total systems power solutions. We have released not only DC-DC converters, but also battery management related products such as charging ICs, fuel gauges, etc. With the comprehensive portfolio, we're able to support wireless handheld and wearable devices with a complete power management solutions. This slide shows the system block diagram of a typical wearable product. We can see that this device requires a battery charger and a fuel gauge IC. It also requires a DC-DC converter to convert the battery voltage to power the system. Richtek can provide a complete power solution to meet those requirements. As shown in this slide, here shows Richtek has solutions in each sub-block to our customers, ranging from battery charging related charger RT9525, RT9471, wireless charging transmitter RT3181A, and the receiver RT1625, battery fuel gauge RT9426A, system required buck converter RT5707, buck boost converter RT6168, 2 boost converter, RT4822, RT4823. Those are high accuracy and low power management solutions. In this system block diagram, you can also see Richtek provides a complete power solution for this type of product. In the right corner of this diagram, it shows a picture of earphone. Richtek's field gauge can be applied to the device like earphones, which require small-sized batteries. And it still has high accuracy in terms of battery capacity measurement. After talking through previous two slides, let's see if Richtek products are actually in mass production for those applications. This slide shows an example of the application with Richtek products in mass production. Here shows some pictures taken from the analysis report of a product teardown. In the diagram, you can find our charging IC, RT9471, field gauge, RT9426A, buck boost converter, RT6168, widely used in this type of products. This can prove that the performance and reliability of Richtek products are highly recognized. Next, let's talk more about these products. First of all, the RT4822, 23, which are 5-volt boost converters. It can be applied in NFC, USB charging port, and applications requiring 5-volt output. Also, you can find that we offer both fixed 5-volt output voltage version as well as I2C adjustable output voltage version. From the application circuit and diagram, the required external components are quite few. It only requires 2 capacitors and 1 inductor. And the size of our IC is also very small. It is hosted in a wafer level CSP9 package. Let's compare our products with our competitors. From a comparison table, you can clearly see that the performance of our product is far better than the performance of our competitors. Apart from the high conversion efficiency, our product's quiescent current is only 10% of the competitors. It will extend your product's standby time and long life cycle. Here shows a low power consumption buck converter featuring only 360 nanoamp IQ RT5707. You can tell from its application circuit that only few external components are required. And the IC size is also small. It is hosted in a wafer level CSP 8-volt package. By checking the table of V-select 1 to 3, you can find a set of output voltages responding to each setting. Next is our buck boost converter, RT6168, which can support a maximum output current of 3 amp. From its application circuit, it can be seen that only few external components are required as well. Also, it has an I2C control interface that can set the output voltage. Meanwhile, we can tell from this graph that its quiescent current is around 2 mA, which is much smaller than the IQ of competitors' product. It can save more power for longer standby time and longer product life cycle. Next, here shows the high-efficiency switching charger ICs, RT9470, RT9471D. We provide products with or without PC 1.2 detection in 2 different packages for options. This product can be used in mobile phones, tablets, etc. For the teardown report presented before, can also be applied to wearable products. Its charging efficiency is up to 92% under 502 amp charging conditions. This is very competitive specification. It can avoid the heat problem during charging, which might cause the temperature to be too high. It brings excellent results in both product development and consumer experience. Next is our fuel gauge. We offer two types of fuel gauges for single-cell batteries. The RT9422 placed in the battery pack and the RT9426A fuel gauge in the system size respectively. Our products can be widely used in the electronic devices with single-cell batteries, such as mobile phones, tablets, wearable devices, IP cam, or doorbell. In this slide, you can see that our RT9426A has two packages, web level CSP and DFM packages for options. Whereas the RT9422A is available in the DFM package for options. What are the key features of Richtek's fuel gauge products? Next, I'll talk through a series of specific topics on fuel gauge. I believe that after this presentation, you will be able to understand why our fuel gauge has been widely used in many devices powered by single-cell battery. First of all, let's talk about what is a fuel gauge. Briefly speaking, a fuel gauge is to measure the capacity of a battery and to record the percentage of power consumption on each function during discharging. It can also do a lot calculation to monitor the usage and state of health of a battery. It can also estimate the capacity of a battery and its standby time. Usually, the state of charge is shown in percentage. In this slide, let's talk about the advantages of our fuel gauge products. First of all, directly perceived from the upper left diagram, it is clear to see that without using high accurate fuel gauge in a product like earphones, there is a huge difference of battery capacity on each earphone. The upper right diagram shows earphones with Richtek's fuel gauge. You can see that the SOC reports of both earphones are consistent and very accurate. Also, it shows very low power consumption because our fuel gauge has only 14 microamp IQ. It can help devices to save more power and thus extend the battery life. Also, because of accurate SOC, it can provide a more stable power usage to the system. The system will not be shut down early because of the wrong SOC reported. I believe you might also wonder why to use Richtek's fuel gauge solutions. Here are some key features of our fuel gauge. First, it has ultra-low power consumption and ultra-high precision. The accuracy of SOC error is within a plus minus 1%. For small capacity batteries, it can also provide very accurate measurement. The current measurement resolution is 0.125 milliamp. It supports very wide range of charging current from 10 milliamp to more than 1C. Last but not least is our product reliability. It can be proved by the shipment record and less than 1 ppm CCN. Next, let me introduce our fuel gauge products. First, the fuel gauge on the system side, RT9426A. Our product can be widely used in devices with single-cell batteries such as mobile phones, tablet, wearable IP camera, doorbells, and other devices. You'll be able to find Richtek's fuel gauge inside. In this slide, you can find that our RT9426A is available in two packages, web level CSP and DFM for options. Here shows a comparison table of our RT9426A and our competitor's product. From these figures, you can tell that performance of our fuel gauge is far better than our competitors. For example, our product's power consumption is only one-fourth of the competitors. It is equivalent to an extra use time of 2 days in a smartwatch. In addition, our product can support R-sense as low as 1 milliohm. It only requires few external components, two resistors and one capacitor. There are three components in total. Compared with our competitor's solution, which requires five external components, you can save two components. This is also a save on BOM cost for customers. Let's move to the fuel gauge RT9422A for the battery pack. Our products are also widely used in devices with single-cell batteries such as mobile phones, tablets, wearable, IP cam, doorbells, etc. If you need to put a fuel gauge in your battery pack, our RT9422A is an ideal choice. Here also shows a comparison table of our product RT9422A and our competitors. You can tell from those figures the performance of our fuel gauge is far better than our competitors. In terms of power consumption, our product only has 1/10 IQ of our competitors. If we take smart doorbell as an example, you get around extra 20 days of usage time with our products. After a brief product introduction, you probably would like to know the actual performance of our fuel gauge products. Next, I'll show you some actual test data to prove the performance of our products. I believe you will feel more confident in choosing our product after understanding the performance of our products. First of all, let me introduce the unique VGCS algorithm of Richtek fuel gauge. I believe a core and key technology of fuel gauge is the algorithm. Our VGCS algorithm is based on voltaic gauge with current sensing to calculate SOC, voltage, current, temperature, OCV table, and FCC as input to generate SOC, SOH, FCC, cycle, TTE, time to empty, etc. The SOC and FCC calculation includes temperature, load, consumption, and aging self-learning functions to achieve long-term stability and shorten linear transition response performance. Next, we will use our fuel gauge to directly test on batteries of some mobile phone in the market. From the diagram, you can see that our fuel gauge can support fast charging function of this mobile phone. From pre-charging, phase charging to full charging, it records the entire process on the charging voltage and the measurement of charging current. In the data analysis of a picture on the right side, we can see that our SOC error is only around 1%. The total discharging capacity exceeds 98.4% of the battery's full charging capacity. In this slide, let's take a well-known mobile phone for a test. From the measurement of the charging and discharging in two pictures on the left, we can see that the charging and discharging curve of the mobile phone battery is very smooth with our fuel gauge. From the diagram on the right, the accuracy of the SOC arrow is also only around 1%. The overall discharging capacity exceeds 99.4% of the full charging capacity of the battery. From these two experiments, we can tell that our battery fuel gauge is very accurate. When it comes to the accuracy of the SoC, I think you might be concerned about the performance other than under room temperature. Whether the performance at high and low temperature is still consistent, because we know that the chemical change of the battery at high and low temperature is not the same as its performance at room temperature. Therefore, let's have a look at how the performance of the SoC charging discharging curve of the fuel gauge at high and low temperatures will be. In the diagram on the left, the SoC charging discharging curve is measured at room temperature. The yellow line is the ideal SoC curve. The blue line is the curve with data measured by our fuel gauge. The red dot line is the data recorded with our competitors. In the diagram, we can see that our measurement SoC accuracy is about 1%, which is more accurate than our competitors. The overall SoC curve also follows the ideal curve. At high and low temperatures, you can see that the performance of our SoC is consistent with the performance at room temperature. All accuracy is within 1%, but the SoC error of our competitors is quite large at low temperature. Those results are under the same test conditions. In this slide, we'll take a look at the performance on a smartwatch, which is a wearable device with our fuel gauge. The diagram above shows the measurement data and the accuracy of the SoC. The diagram below is the information on discharging voltage and current. The left diagram shows a test condition where we recorded heavy use from full charge to dead power within 1.5 days. The middle diagram shows that the average battery cycle is about 7 days under normal usage. Under these two test conditions, we can see that the reported accuracy of our SoC arrow still maintains the same level of performance. Whether the battery discharging is a periodic steady discharging or a discharging condition is with severe load change, we can provide you with a fairly accurate SoC performance. On the right-hand side, it shows the charging curve and SoC measured with this watch. It can be seen that the fuel gauge performance of the small capacity battery system is also unquestionable. After showing you the small battery charging and discharging system, let's take a look at the performance on charging and discharging with high C-rated batteries. In this slide, we can see whether it is charged with a 1.8C or 2.5C battery. The SoC accuracy of our fuel gauge is very high. As a result, showing the high performance allows us to smoothly introduce our solutions to mass production for some smartphones with fast charging in the market. As I mentioned, there are many factors that affect the measurement of the battery power capacity, including change in temperature and change in load. So here we will take a look at the performance of our fuel gauge under different temperature and load changes. In this diagram, The pink curve is the temperature and the yellow curve is the load. Upper left diagram is the temperature change from room temperature to high temperature. Upper right diagram shows the change from low temperature to room temperature, along with the load change below. You can see that in this application scenario, the SOC reported by our field gauge still stays in the same high performance. Its accuracy will not change because of severe temperature or load changes. I think everyone knows that entire electrochemical reaction of a battery under low temperature conditions is very different from it at room temperature or high temperature. At low temperature, the battery power measurement is quite a challenge. Let's take a look at the experiment of charging and discharging with a 4,500 mAh battery at a lower temperature to see how its SOC performs. This slide shows that the experiment was taken at a low temperature of 5 degrees Celsius. The diagram on the left-hand side is the charging experiment. The middle one is the experiment of discharging with a load of 100 mA. The diagram on the right is the test of discharging with a heavy load around 2 amp. From the three diagrams below, you can clearly see that our SOC curve is close to the ideal SOC curve. The overall SOC error is also only within 1% to 2%. Let's take a look at the performance of a battery power measurement under the same discharging condition, but at a lower temperature of minus 20 degrees Celsius. In the diagram below, our SOC curve is still close to the ideal SOC curve. The overall SOC error is also within 1 to 2%. From test result at low temperature in those two slides just mentioned, you can clearly see that the performance of our field gauge will not change at low temperature or extremely low temperature. Last but not least, let's take a look at the performance of FCC learning. FCC refers to the field charging capacity. What does it mean? It can indicate the health of battery. I believe that viewers who have used iPhones should know the health of a battery is measured in the system, and the health of a battery is calculated through FCC learning. We all know that the battery will age with the increase in the numbers of charging and discharging. In the two diagrams above, we recorded the battery state of health from the beginning of discharging to 450 cycles of charging and discharging. Our FCC learning can control the battery aging and error compensation calculation within 2%. With the VGCS algorithm, the SOH error calculated is also within 2%. The SOC error of a battery is controlled around 2% after long use. Therefore, our field gauge product will not affect the accuracy of a battery capacity measurement due to the aging of the battery after a period of use. This is what a high performance and high accuracy field gauge product should be. I have talked so much about the performance of our field gauges. I believe that you have a better understanding on Richtek field gauge and would like to try our products. But you might still have some question about how to design field gauges. Because we understand to design a field gauge requires a lot of technical support. Next, let me introduce the entire field gauge design flow. Here shows a reference flow as an example, from project development to mass production. After starting your project, our FAE or AE will assist in reviewing the customer schematics. At the same time, we will require the customer to fill in the model information sheet and provide samples of batteries and battery specifications. Next, our FAE will assist in reviewing the layout of the field gauge IC and the peripheral circuits to ensure that there is no other factors such as voltage, current, temperature to affect the estimated power accuracy. After collecting the modeling information sheet and battery specification, our AE will design the test application conditions according to the information provided by the customer and start the battery modeling test. After the PCB is printed and sent back, our AE will recommend whether the PCBA calibration is required based on customer's accuracy test results. If a resistance is less than or equal to 5 ohm, it is recommended to calibrate each board individually or do a batch calibration. Using parameter setting to correct the same deviation of all boards. Generally, if the current detection resistance is larger than 5 milliohm, and the layout is ideal, it doesn't require additional calibration procedures. After the modeling test is completed, A will provide a corresponding ECU based on the platform used by the customer or Linux reference code. The final procedure is to verify customer's final project. Most of the customer's test results can meet expectations on the first version of the coding and ready for trial production. Only a small number of customers will need to adjust the parameters based on their feedback on the test results of the final product. Here is an example of a battery modeling sheet. The customer needs to fill in the battery's rated capacity before providing the extra batteries. The reference value will affect the battery capacity, SOC, FCC, and estimated performance related to battery agent. Charging criteria such as CVCC, IEOC, and other reference values will influence the estimated performance on 100% charging. The estimated battery efficiency, open circuit voltage, OCV setting, discharging load, and end of discharging conditions, which means light load, heavy load, EDB, etc. These reference values will determine whether the battery capacity is discharged to 0%. The estimated battery capacity and the battery open circuit voltage OCV, temperature detection resistor, and NTC should have the corresponding settings to detect accurate temperature information and to get accurate estimated value of battery capacity. In order to build a good battery model, we have to define the test criteria and take product design specifications, electrical specifications, application specifications into consideration. The following is a reference example. First, defining charging procedures and criteria based on the electrical specifications and system charging conditions. Most customers use standard CC and CV charging, but some customers use fast charging topology of step charging to define these discharging conditions. The test conditions of charging and discharging will be defined by the longest standby time and the usage time of maximum load of the product. The charging and discharging test criteria includes the temperature conditions of a product, such as charging and discharging at room temperature, high temperature, low temperature, and even negative temperature. Richtek's fuel gauge solution includes complete technical support, including all related documents, driver reference code, source code, and software documents. In addition to datasheet, OTR documents describe the advanced setting and definitions of the relevant registers. If customers have any confidentiality issues to provide battery information to build a model, we still can test it under conditions defined by the battery characterization guidelines to provide test data. And then our company will generate the reference code. For pack-side fuel gauge RT9422A, you can refer to the programming and calibration guide for parameter configuration and measurement calibration on the production line. For the 6-ton side fuel gauge RT9426A, you will provide the reference code of corresponding MCU or Linux driver based on customer's application platform. The development evaluation kit includes EVB and GUI Software Gauge Studio. Customers can refer to the Quick Start guides to start connection and test. As mentioned above, it is the content of today's webinar. I hope you enjoy it and find it helpful to design and choose any future products. I'm Mason from Digital Marketing at Richtek Technology. Thank you.